Welcome to qnawire.
For this problem, we have a particle moving under a central force. So this means that the angular momentum per unit mass, h, is constant. And hence we can write h, since from equation 12.27 we know h is r squared theta dot. And since it's a constant, we can call this h naught. And h naught is simply r naught v naught. So its initial position r naught times its initial velocity v naught. So if you rearrange this equation, we can write theta dot, which is d theta dt, as r naught v naught over r squared. But we are given an expression for r. So if we substitute that in here, we get this to be r naught v naught multiplied by cos 2 theta over r naught squared. And so this simplifies to v naught over r naught times cos 2 theta. So we have an expression for theta dot in terms of v naught, r naught, and theta. So now let's try and find the radial component of the velocity. So the radial component of the velocity, Vr, is equal to dr dt, r dot. And dr dt, by the chain rule, is dr d theta, theta dot, dr d theta d theta dt. And so this can be written as d theta of r, which is r naught over the square root of cos 2 theta times theta dot. So remember, we already have an expression for theta dot that we've derived above. So Vr becomes r naught into sine 2 theta, if we find the first derivative with respect to theta, over cos 2 theta to the power 3 over 2 times theta dot. So now that we've done the differentiation with respect to theta, we can open out theta dot. And what we get is r naught multiplied by sine 2 theta over cos 2 theta to the power 3 over 2 times v naught over r naught cos 2 theta. And so simplifying, we have an expression for our radial component of velocity in terms of theta to be v naught sine 2 theta over the square root of cos 2 theta. And there we have our radial component of velocity as required. So the next thing we need to do is calculate the transverse component of the velocity. And that's v theta. So v theta is equal to the angular momentum per unit mass, h, divided by r. And h, remember, is r naught v naught, and r, we have an expression for r naught is the square root of cos 2 theta. So simplifying this, we get an expression simply for the transverse component of the velocity the r naught cancels, so this becomes v naught times the square root of cos 2 theta.